Hmm. And so this is one of the ways, from what I understand, that the fungi kingdom is closer to the animal kingdom than the animal kingdom is to the plant kingdom. Is that correct? Like, for example, plants make their own food, animals and fungi consume food from their environment.
Absolutely.
And
Absolutely.
there's other similarities between animals and fungi compared to animals and plants too. Is that right?
Absolutely. I mean, there's a lot of them, but one of them is the one that interests me a lot is was actually identified sort of in the pre-molecular age of biology, because now we can compare the genomes of fungi and animals and plants and everything else, and we can actually calculate their degree of similarity and evolutionary relatedness. But I think this was really interesting observation that was made first in the 1980s, was that the only organisms that produce a cell with a flagellum, a cellular tail that I'm doing all these hand movements in this interview today, but there aren't many things you can do. There's a
Sure.
fungus. Anyway, a tail that undulates, that vibrates, and actually pushes the cell through fluid. So animal sperm cells do this, but also the cells of aquatic fungi called chytrids, and there's actually other kinds of fungi that live in aquatic environments. They produce swimming cells too that swim in exactly the same way with a tail that pushes the cell through the water. There's nothing else like that in nature. So me, with my obsession with pond water, I see cells that are swimming around all the time using cilia or flagella. These are the terms that we use. Then they're arranged in a fundamentally different fashion, where they're not acting as an outboard motor that pushes the cell through the water. They may be pulling the cell through water. They're working in different ways, but that particular arrangement of the single flagellum on a swimming cell is something that we only find in animals and fungi. So that in itself is a structural characteristic that unites these organisms. And this very smart, although tremendously annoying scientist pointed this out in the 1980s. He just recognized that. I thought that was a really brilliant insight before we'd done the genetic analysis that showed the similarity between fungi and animals.
Mm.
Yeah, so we fungi and animals exist in what we call a supergroup. It's something larger than a kingdom. So we might regard the animals as a kingdom, kingdom Animalia, and the fungi as their own kingdom. But they exist in this supergrouping where they're united and separated from many other forms of life.
So that if we go back evolutionarily, there was a common progenitor between fungi and animals. Hmm.
Then there must have been, yeah. I mean that's yeah, that's evident from the structure that I mentioned, other kinds of cellular structures that are in common between fungi and animals, and also this profound genetic similarity. I mean, it's profound, and yet, we're talking about separation that occurred a billion years ago. So there's a lot of evolutionary history through which we've been separated, but nevertheless, at our base, there we are. We're far more like fungi than we're like brown algae kelps, for example, or plants, or diatoms, or dinoflagellates, all of these other beautiful forms of eukaryote life. Yeah, we're united with the fungi, which is interesting, which is
Interesting. Uh,
inspiring.
less have a less scientific reason to state the same in my own life, but we can leave that aside. Uh,
We can go to that. The other thing is though too is that this has been uh, discussed for years is that when we develop very serious fungal infections, they're very difficult to treat. So the most serious fungal infections, usually we develop those because our immune systems are compromised for one reason or another, and we could discuss that. But it's because of the profound similarities between the biochemistry of the fungi and us. It's difficult to develop a drug that kills these fungi without damaging our tissues. And that's the reason why most of the most powerful antifungal agents are very toxic. We have to take them in quite high doses to deal with a fungal infection, and they lead to kidney and liver damage and so forth. So even there we're seeing traces of our evolutionary heritage and what
I'm gonna
close close affinity to the fungi.